going to look at arithmetic series and how we actually find the sum of that arithmetic series. So sum to n, we said, was the sum of all those terms. So I could say, well, first term is a, then we're going to add a plus d, then a plus 2d, all the way to whatever the last one is, which I'll just call L for last. That means the second last one would be L minus the common difference. And the third last one would be L minus twice the common difference, and so on. In fact, that's so good, I'm going to write it again. But backwards. Now when we write it backwards and think of it as now simultaneous equations, we see an interesting thing happening. If we just look in each column, we've got a plus L, but then we get to a d and a negative d, which would cancel. A plus L, d, negative 2d, which will cancel. And that pattern is all the way along, so we'd end up with two lots of the sum. Will be a plus L plus 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 a plus L, and so on. So the question is, of course, how many a plus L's do we have? Well, it was each term in our pattern was creating this column of a plus L, and we know there were n terms all up, so I must have n lots of a plus L. Hence we get our formula, divide both sides by 2, there it is. Now that formula is handy if we know the first and the last term. Sometimes we don't know the last term, but that's alright, because what we can do is substitute in the general term for the last term, a plus n minus 1d. And that gives us an alternative one, tidy it up, and that explains why the summed formula actually is 2a plus n minus 1d, because it was a plus the general term. Okay, so we've been given the first terms 3, the sixth terms 96. Let's find the sum of the whole series. Well, in this case I do know the last one, so I may as well use the a plus L formula, and it's just a substitution question. So 3 plus 96, and then multiply that by 3, 297. Find the sum of the first 100 even numbers. And let's just pretend for a second that I don't know what the last of those even numbers is. Oh boy, 100th even number? No, I can't work that out. So in this case I'll use the other formula. First term's 2, common difference also happens to be 2, and there's going to be 100 of these even numbers. So we put it into the 2a plus n minus 1d. Sub in, and again, bit of calculation, there it is, 10,100. Thing to watch out with the sum to n formula, the most common mistake, and you may have even done it yourself, is putting a plus n minus 1d, because we're so used to that with the general formula. So remember, it's 2a plus n minus 1d. Okay. Now the sum of the first 10 terms is 100. First 5 is 25, so we've got to find all the bits of information. What's the first one, the difference, and then the formula for the general term. So okay, the sum to 10 is 100. I don't know what the last term is, so I'm going to use the a plus n minus 1d formula. So 10 on 2, 2a plus 9d. So I get one equation that links a and d together. The other bit of information, they've told us sum to 5 is 25. So 5 on 2, 2a plus 4d is 25. I've now got two equations, two pronumerals, so it should be possible to find each of these with simultaneous equations. So we're doing that. 5 differences is 10, so now the common difference is 2, and then you can just go backwards and work out the other bits. So the first term is 1. They also wanted the general term. Well, that's a plus n minus 1d. Subbing into that, 1 plus n minus 1 times 2 tidies up. 2n minus 1 would be the formula. Okay, here's one in sigma notation. But I noticed that the general term here is in the form of an arithmetic one. If we see some multiple times n, and that's all, there's no other n there, then we know that's going to be an arithmetic one. Geometric, I'd be looking for the n in the power. So I know I can use my formula rather than having to write out all 10 terms and then adding them together. So the first term we sub in 1, the last term we'll sub in 10, and there's 10 terms all up. So I can use the A plus L formula, and there's my answer, 105. So hopefully we recognise it and we go, oh yes, that's going to be arithmetic, because I recognise that general term is in the form of an arithmetic series. Saves a lot of time rather than having to substitute in every individual bit. Okay. Oh, but on that, be careful, because that was 1 to 10. If it was 3 to 10, to get the first term, you'd sub in 3. But how many terms would you have? Nope. 8. One more. Because it's inclusive. Because you've got the third term and the 10th term, so you do a subtraction, but then add one back in. Okay. 6 I will play with today.